Hello students, welcome back to the class. In this chapter, line and angles, we study the different types of angles, different types of pairs of angles, and the two axioms. The axiom tells us if a ray stands on a line, then the adjacent angle that created by that ray, the sum of those two adjacent angles is equal to 180 degree. And next we will see the theorem based on this axiom. Theorem 3.1, the first theorem of this chapter, it says that if two lines are intersecting each other, then the vertically opposite angles are equal. We know the vertically opposite angles means if two lines are intersecting, the opposite angle for each other, that is the vertical opposite angle. Here AOD and COB are vertical opposite. AOC and BOD are vertical opposite. I mentioned here the angles in separate lines. Here AOC, which is the angle which I draw in a single arc, and BOD also I mention the angle in a single arc, so that these two angles are same. I am mentioning in this way. I am considering these two angles with two arcs. That means these two angles are same. To notate the angles are same, I am using one arc and two arc. So let me prove this. First, let us write what is we did in this figure and what we are considering. Okay, first the AB and CD are two lines intersecting on the point O. These two lines are intersecting on the point O. Therefore, angle AOC and angle BOD are vertically opposite angles. AOC and BOD, these two are vertical opposite angle. Also, angle AOD and angle BOC are vertically opposite angle. These two are the vertically opposite angle. This we got from the diagram, and that is the half of the portion of this statement. So what we have to prove? The vertically opposite angles are equal if two lines are intersecting. That means we have to prove angle AOC is equal to angle BOD and angle AOD is equal to angle BOC. Let me check for the this angle using the protractor. Just get the value of AOD. The value of AOD I am getting, this is 85, and here I am getting, this is also 85. While measuring the angle, we are getting AOD and BOC are one and the same. To prove this theoretically, let me consider one line. Let me consider the line CD. Let OA is a ray stands on the line CD. And you can observe, if you think only this portion, upper portion, OA is a ray stands on the line CD. What we know in the linear pair of axiom that we studied in the previous class, if a ray stands on a straight line, the adjacent angle sum is equal to 180 degree. Therefore, the adjacent angles are AOC plus AOD, which is equal to 180 degree, because linear pair axiom. Because of the axiom, depending on the linear pair angle, AOC plus AOC, this angle, plus AOD, this angle, sum is equal to 180. Similarly, I can tell angle AOC plus angle BOC is equal to 180 degree. I am giving the reason, linear pair axiom. Can you guess why it is so? Just observe this line AB and the ray OC. See, OC is a ray stands on the line AB. That means the adjacent angle of, depending on this ray OC, their sum is equal to 180 degree using linear pair axiom. So AOC and COB are two adjacent angles for the ray OC stands on the line AB. Their sum is equal to 180 degree. Therefore, AOC plus BOC is equal to 180 degree. Take this as equation number 1 and equation number 2. Observe, the right hand side of the equation number 1 and 2 are same. Therefore, the left hand side should be same. Therefore, from 1 and 2, angle AOC plus angle AOD, this expression is equal to angle AOC plus angle BOC. This expression. These two are same from the 1 and 2. Right. Can you see here? This angle and this angle are common in both sides with the addition symbol. So I can cancel these two angles. From that I will get AOD is equal to BOC. Now you can observe we already proved this. AOC is equal to BOD. That is nothing but the opposite angle AOD and BOC are same. So that our statement is proved. We can also prove this statement or this expression. So that if two lines are intersecting each other, then the vertically opposite angles are same. This is a proof of this theorem. Okay, the first example is, in this given figure, PQ and RS are intersecting, are the lines which is intersecting each other at the point O. And the ratio between two angles are given, PQR and ROQ. These two angles ratio is equal to 5:7. Find all the angles. Let me solve this. They are given angle POR is to ROQ is equal to 5:7. This is given thing. And we know PQR and ROQ are linear pair of angle. If we add those two angles, their sum is equal to 180 degree. Because PQ is a line and OR is a ray stands on a line. Using the axiom, we can tell angle POR plus angle angle ROQ is equal to 180 degree. So the ratio means if I divide the angle, into 12 parts, in that 5 part is POR and 7 part is ROQ. So that out of 12, 5 part belongs to POR and 7 part belongs to ROQ. Here the total angle is equal to 180 degree. So the angle POR is equal to, if I divide 12 parts, 12 part means 5 plus 7, total it is 12 part, in that 5 part is POR, right? Out of 12, 5 part is POR. The total angle is equal to 180 degree. So answer for this is POR is equal to 5/12 into 180 degree. 5/12 into 180 degree. Let me solve for this. 3 4s are and 2 6s are, 2 6s are, 2 90s are, 3 2s are, 3 30s are, 2 1s are, 2 15, 15 5s are, 15 5s are 75 degree. So POR is equal to 75 degree. Similarly, I will get the ROQ. ROQ means out of 12 parts we have 7 part is ROQ. The total part is 180 degree. You can find this way. Then it is equal to 150 in the 100 and okay 115 105 degree. 15 7 is 105 degree. Okay, or else you can find using this. We know PRS we are getting 75 degree plus ROQ is equal to 180 degree using this expression. So ROQ is equal to 180 minus 75 degree is equal to 105 degree. There are two methods to get the ROQ. Clear? Now I am getting POR which is equal to 75 and ROQ which is equal to 105 degree. And they are mentioning that find all the angles. We found two angles, so we need to find two more angles, right? So this is the way. And we also know from the theorem number 3.1, if two lines are intersecting each other, then the vertically opposite angles are same. Now let me give the hint. Here POR and SOQ are vertically opposite angles, right? PQ and RS intersecting means POR and SOQ are vertically opposite angles. From the theorem 3.1, if two lines are intersecting, vertically opposite angles are same. So these values should be same since POR is 75 degree. Therefore, SOQ value is equal to 75 degree. Similarly, ROQ is equal to POS. ROQ is equal to POS. These two are two vertical opposite angle. ROQ we already got, it's equal to 105. So POS also equal to 105 degree. This is the use of the theorem number 3.1. If you know the ratio, or if you know one angle of this intersected line, we can find all the other angle related to this these two intersected lines. Okay, the next example is this. This is quite an interesting one. Okay, in this figure, ray OS, this ray OS stands on the line POQ, and ray OR and OT are angle bisects of POS and SOQ respectively. If POS, this angle is equal to X, find the angle ROT. It is quite interesting, and it has some trick to get the solution. And what do you mean by angle bisector? Angle bisector means if any angle are given, one ray, it curves the angle into exactly two parts. That is nothing but the angle bisector. Here they are given OR is the angle bisector of POS. This ray OR bisects the angle POS, or this OR divides POS into exactly two parts. If it is equal to 10, then this is 5, this is 5. If it is equal to 40, this is 20, this is 20. So the angle is divided exactly two times, or exactly half of the original angle POS. Similarly, OT is the angle bisector of SOQ. OT is the angle bisector of SOQ. If SOQ, this angle is equal to 80, then these two angles are 40 each. Clear? The angle bisector. They are also mentioned here using the one dash on the arc of the angle. That means these two angles are same and these two angles are same. If this is X, this is also equal to X. Clear? It's about the bisector. And they are mentioning that angle POS, this angle is equal to x. Angle POS is angle is equal to x, and they require angle ROT, this angle. What is the value of this angle? Let me solve this. Solution. First, what they are given angle POS is equal to x, and OR and OT are angle bisector of POS and SOQ respectively. Okay, in this I can tell, okay, it's okay. And what they are given, OS stands on the line, on a line POQ, or I can, it is a PQ line also. These are the our required things. If a ray stands on the line, what we know? If a ray stands on the line, its adjacent angle sum which is equal to 180 degree. Here they are mentioning that the line OS, this line OS stands on the line POQ. Therefore, now just observe, therefore angle POS plus angle SOQ which is equal to 180 degree. Clear? POS, this angle, plus SOQ, this angle, which is equal to 180 degree, because these two are adjacent angle when a ray stands on the line POQ. Therefore, their sum is equal to 180 degree. And they are also given POS is x, any angle x. So I am replacing this as x plus angle SOQ which is equal to 180 degree. Therefore, angle SOQ is equal to 180 minus x degree. 180 degree minus x degree. So here they are given x. I am getting, or we are getting, this angle as 180 degree minus x degree. Clear? So you think this angle is x. Since this line ray stands on this line, so this is nothing but total 180 degree. We have to neglect x. So this angle is 180 degree minus x. And from these two, OR is a angle bisector of POQ. OR is an angle bisector of POQ. Before that, let me give the hint. What we have to find? We have to find the angle ROT. We have to find the angle ROT. Look at here. The angle ROT, which is the combination of ROS plus SOT. I can write this is the continuum ROS plus SOT. Right? ಇದು ಫುಲ್ ಆಂಗಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಎರಡು ಆಂಗಲ್ ಸಮ್ ROS ಮತ್ತು SOT ಅದು ಸಮೇಷನ್ ROT. Can you find ROS? This angle, only half of the ROT or the portion of the ROT? Yes, we can, because these two angles are same. If the whole thing is x, this portion is x by 2. As I already told, if this is 40, this portion is 20. If this is 50, this is 25. This is 100, this is 50. So, from the figure angle ROS, which is half of the angle POS. Angle ROS is the half of the angle POS, and POS are given which is equal to x degree. So ROS is x by 2 degree. Here ROS is x by 2 degree. Similarly, I can tell SOT. Angle SOT is half of the angle SOQ. Idradu arda, because these two are the equal angle, because OT is a bisector of SOQ. and we know 180 minus x. Therefore, this is 180 minus x degree whole divided by 2. 180 minus x degree whole divided by 2. Or I can write this as 180 by 2 minus x by 2, or 90 minus x by 2. So this is 90 minus x by 2. So I got ROS as x by 2 plus SOT as 90 degree minus x by 2. Plus x by 2 minus x by 2 gets cancelled. The remaining are 90 degree. What we have to find? We have to find ROT. We got the value of ROT. It's equal to 90 degree. So this is the required angle for our problem. The answer is 90 degree. It's interesting, right? Using all the theorems and all the properties of the angles. Okay, next we will move further. This example, it is given that OP, OQ, OR and OS are 4 rays. Prove that POQ, QRS, SOR and POS is 360 degree. POQ, POS, SOR and ORS, the total angle is equal to 360 degree. That we have to prove. So write the solution. Given OP, OQ, OR and OS are 4 rays. OK and OS are 4 rays. Let me draw one line such that it is a straight line for the ray OQ. I will draw one more ray, one more imaginary ray OT. Okay, that means TOQ become a straight line. I am drawing. Draw the ray OT such that TOQ is a straight line. TOQ become a straight line, so I have to draw OT. Okay, next just observe, this is a line PO stands on the line O TOQ, so their sum is equal to 180 POQ. Therefore, angle POQ plus angle TOP is equal to 180 degree. Right? From the linear pair axiom, this angle POQ plus TOP is equal to 180 degree because linear pair axiom. Because of this linear pair axiom, this sum is equal to 180 degree. Next, now check here. If I take OS is a ray, stands on the line TOQ, and since OS is a ray, stands on TOQ, that their sum TOS plus angle SOQ is equal to 180 degree. So this angle plus this angle is equal to 180 degree because this is a straight line. OS is a line, stands on a straight line. And you know, SOQ is the sum of SOR angle plus ROQ angle, right? The whole angle is the sum of these two angles. I can replace SOQ as SOR plus ROQ because angle SOQ which is equal to SOR plus ROQ. Why I am substituting? We have to prove POR plus QOR plus SOR plus POS is equal to 180. So I require SOR and ROQ should be there in our expression, in our equation. After substituting this, now take this as equation number 1, take this as equation number 2. Add 1 and 2. What you will get? The angle POQ plus angle TOP plus this expression TOS plus SOR plus ROQ is equal to. Now I am adding the left hand side POQ plus TOP plus TOS plus SOR plus ROQ. Okay, it's equal to 180 plus 180, it's equal to 360 degree. Clear? Now here there are only 4 angles, we are getting 5 angles, right? Why? Because we are taken the imaginary ray OT for our calculation, right? Now look at this, TOP and TOS. What is that? TOP plus TOS. If you add these two angles, what you will get? You will get angle POS. So this is angle POS. Okay, that means angle POQ plus angle POS plus angle SOR plus angle ROQ is equal to 360 degree. So we got all the angles sum is equal to 360 degree. You can compare here POQ, but here QRS we are getting ROQ and SOR correct and POS correct. I can name this angle ROQ as QRS also. So I can replace this as angle QOR. Okay, and since this is a positive sign, I can shift those angles in other direction in the other place. So it is QOR plus SOR plus POS which is equal to 360 degree. That we have to prove. I can change their place because it is in the left hand side only and addition sign, and replacing QOR and POS position, then the required then the expression what we are getting is our required proof. Okay, these kind of examples which is easy and sometimes it is tricky. There are some more exercise problems in your textbook. Please solve all those exercise problems. In the next video we will see some more extra concepts of lines and angles. Okay, thank you.